to factor polynomials with 4 terms. Factor by grouping. It's used to factor polynomials with 4 terms. Raymond, you should put that away. You can probably take that out of your ear too. Thank you. All right, I'm going to show you that in a minute. To factor completely, which you've seen in your directions already, but maybe you weren't sure what it meant. It means when you are finished factoring, when you are finished factoring, nothing else can be divided out or factored This word is probably a completely improper sentence, but that's okay. Basically, to factor completely, it means when you're finished factoring, nothing else could be divided out or factored from each factor that you have. You gotta just look at that and say, can I go any further? Basically. All right. Ready? Let's look at this. This is actually a polynomial that's already done the first step of grouping, and we're going to finish it. What do you notice in this polynomial or expression? What do you notice? There's something hopefully you notice in here. It's been undistributed, correct? And what is left when they undistributed? What do you notice here?
It's an x and 3.
Oh, look at these two binomials. Notice the same binomials. Notice the same binomials. That means that 4x is being multiplied by that binomial and 5 is being multiplied by that binomial. So what I can do is I can do this. Watch. I'm going to take the 4x and the 5 and I'm going to put it together into one binomial. And then I'm going to take this and just write it once. Because what's actually happening here is 4x is being multiplied by x and 3, and 5 is being multiplied by x and 3. And so you're done. There's your answer. Boom. That's like the second step in grouping. Okay? Let's do another one. What do you notice is the same here? X minus 2 and x minus 2, right? So I just take this x and, uh-oh, what's in front of here? Oh, there's an x and a 1. And I group them together, x plus 1, and the x and the 1 are both being multiplied by x minus 2. And you're done. Okay? We are not doing that one. All right. So now we have to take and do the first step of grouping, and then we'll finish with what we just did. So I have 4 terms. 4 terms. Are they in standard form? Yes, they are decreasing exponents. They are in standard form. 4 terms in standard form. You got to make sure that that is happening. Now you can group. What we do now is we put parentheses in to group this polynomial. And then I'm going to look at this binomial right here and say, what can I factor out of both of those? These 2 terms, what can I take out of both of those terms? I can take an x squared out of both of these, which is what I'm going to do. And I'm going to undistribute that x squared, bring it out front. And what do I have left? X plus 2. I'm going to put the plus sign. And I'm going to look up here at this term. What can I take out of both of those?
8.
An 8. So I'm going to write plus 8. And then what's left? Oh, would you look at that? They're the same. Isn't that nifty? That's what you need. You need to look to make sure you get the same thing in both of those. And then you can group. You can say, okay, I know that x squared plus 8 times x plus 2 are my two binomials. That's called grouping. When you have 4 terms. You can't do it when you have 3, but when you have 4, you can do it. Okay? Let's do this one. Now, this one's a little tricky because you can't tell if it's not in standard form or not. But if I take a look at this and if I group these two, I can pull something out of here and I can pull something out of here. So sometimes it's all good. What can I divide out of here? An R. So I'm going to do that. Put the plus sign that's in between there. And then what do I need left when I take something out of here? I need R plus 4, don't I? So what would I divide out of each of these? S. And I still then have R plus 4. I need those to be the same. And then I can just write R plus S times R plus 4. And I'm done. I can't go any further. Neither of these can be factored any further. This one's very similar, so we won't do that one. But let's do this one because it's got a minus in it. Okay, I'm not going to jump in right now and group. What do I have to do first? What did I say up here you have to do first? Standard form. I got to rearrange it so it's written in standard form with decreasing exponents. So the x cubed will go first. What will come next? Plus 2x squared. What will come next? And minus 10. Now I can group, but here's a little bit of a problem. When you have a minus here, it kind of can screw you up. So instead of writing it as a minus, I think you should write it as adding a negative. Change that subtraction to adding a negative. You can change both of them if you want. It doesn't matter. Because now when I put my parentheses, I can clearly see the signs of those numbers. And I have a plus sign in between. Focus up here. What do I take out of both of these? X squared. Pull that out. Put the plus sign that's in between there. What do I have to have left? What do I have to have in here when I take something out? I got to have what? So what can I divide out of both of those to end up with x plus 2? A negative 5. Correct. So I'm going to pull out a negative 5. And I do end up with x plus 2. And then I can just write x squared minus 5 times x plus 2. Okay, now, I don't always use grouping. I'm going to show you a box. It gets a little tight. You can also use a box. Okay, I have a question for you. How many terms did we start with? 4. How many squares are in this box? Oh. If I take each term in standard form and I write them in this box in this order, x cubed, 2x squared, negative 5x, and negative 10. Then it's just like you did before. 4 terms, 4 squares. What can I pull out of this top here? I can pull out an x squared, x, 2, negative 5, and look at that. You end up with the exact same thing that we did with grouping. Either method. Okay? It's pretty nifty, don't you think? Get excited about factoring. All right, now this one's kind of funky, so I do want to talk about this one. This is one of those that you have to look at and say, If I put parentheses around here, can I divide anything out? Let's just try switching the order of this. And sometimes you just have to play with it. Maybe it doesn't always work the first time, and if you switch the order, it will work. So I'm going to write it like this. Y squared plus yx plus 2x plus 2y. Now I could group, or I could box. Let's group, since that's what we're doing. Group. What would I pull out of here? A y. Now we'd be left with y plus x. Put the plus sign. What would I pull out of here? 2, and I would be left with x plus y. Same thing. You could switch the order. In addition, it's fine. So then your answer would be this. I just have to do a few on the back side. And you could do a box for this too. It would work. Okay, turn it over. We're going to do 4. Okay, don't panic. We're only going to do 4 back here. All right, let's do this first one. Remember, hey, didn't I say when A is 1, all I got to do is look at the -3 and say what factors of -3 add to -4? Factors of -3 that add to -4. What do you think, Chuck? Okay, so he says -3 and -1. If I multiply these two together, am I going to get -3? No. Is there anything else that you can think of? What? Positive, -3, and positive 1. Okay, multiplied together, I get -3, but added together, I don't get -4, do I? Sometimes nothing works. So there are no factors of -3 that add to -4, so it cannot be factored. Can't factor it. Nothing works. If you did a box, it wouldn't work either. Box and diamond? Nope. In Chapter 10, you get to learn the quadratic formula. And then we'll be able to solve that. We'll get to sing it. Looking forward to that too, huh? All right. Let's just do one more. No, let's do this one here. Okay. Moving on. What can I take out of each of these before I do anything? I want to just stop a second. I forgot to mention something. How does this side look different than what we were doing here? Does anybody notice? These are trinomials and binomials. You're not going to do the grouping unless you have 4 terms. Okay? We're going to use the other methods we've learned. So I'm going to pull out a 3x from each of those. And I'm left with x squared minus 7x minus 18. 18 is not a perfect square, so I'm not going to use the special pattern. I'm going to use a box or a diamond. And we're not going to spend time doing that. I'm just going to tell you what it is because I can do it in my head. It's x minus 9 and x plus 2. And then you're done. You factored completely. I can't do anything else to these. That's as far as I can go. Let's do this one. What can I take out of both of those? 3x. And I have x squared minus 4. Are we done? Is that factored completely? No. What can I do to this? Raymond? This can go further, can it? How do I know that? What is 4? Chuck? Oh, it is one of those special patterns. 4 is a perfect square. So I'm going to write my two binomials and put x and x. And what's the square root of 4? 2 and 2. But there's no middle term. So what has to go inside here? Plus and minus. That causes there to be no middle term. Now you're factored completely. Oh, one more and then we're done. Let's go down here. What are the directions? So I have to factor and then solve. Okay? What can I divide out of each of these? W, W, W. Take a W out. Equals 0. Do you have to use the box and diamond here or not?
No.
No? How do I know that?
16.
16 is a perfect square. And I can take, so I'm going to do this. I'm going to just write my binomials and start filling in what has to go in the front. WW. And what's the square root of 16? Now, this is where that you kind of have to remember. If it's a minus and a plus, what goes in here? Minus, minus. Because, let me just show you why. You can check really quick. Negative 4W combined with negative 4W gives me, oh, I'm supposed to have a W here. Sorry, it's supposed to have a W. Gives me negative 8W. Oh, but we're not done. Come on, don't get too excited. Let's finish it. Finish it. We got to solve it. This is a factor. I have to set that equal to 0. This is a factor, but they happen to be the same, so I only have to do it once. This is one of my answers, and W equals 4 is my other answer. Pardon me? Now let's do about 6 more. I'm just kidding.